Hello, everyone, and welcome to today's Monsoon Awareness Week 2016 talk. We are going to be talking about downburst winds today. I had to change the link real quick, so I hope people can join us. If not, we'll get this recorded and they can see it at a later time. But we are all week long, we're talking about different threats related to monsoons and the thunderstorms and different kinds of weather that come with the monsoon. Monday was flash flooding. Yesterday was a great conversation about lightning. Today we are talking about downburst winds. Tomorrow is sometimes the result of those downburst winds, the dust storms and haboobs. And finally on Friday we're going to be talking about heat, which, as I understand, looking at the forecast, looks like it will be very appropriate for almost all of us because it's going to be getting very hot most of the places across the Southwest. But the other thing I remembered is that today is the official start of monsoon season. Now, some people may ask, well, if it's monsoon season, I don't see any thunderstorms, or I don't think there's many thunderstorms in the forecast for us. But just like hurricane season, you don't always have an active hurricane going on. Hurricane season runs from June 1st through the end of November. And you don't have active hurricanes those whole times. It's just the time of year when you can get hurricanes. Same thing for the monsoon season. It runs through mid-June through the end of September, and that's just the time of year that we can get that monsoon flow, that moisture, and the different weather associated with the monsoon season. So, having said that, we can all celebrate the start of monsoon season, yay! And I'd like to introduce everyone joining me on the call today and watching along with us. So, first of all, from the Phoenix office, I think you're at home today, aren't you, Paul?
I decided to come home today, yeah.
I don't blame you. I was at home the last couple of days. Paul Enriquez, he is the Sioux over in Phoenix. And then next to him is Carrie. Carrie is the WCM in Albuquerque. And Carrie, who's joining you today?
Hey, good evening, everyone. This is Todd Shoemake, one of our newest lead forecasters and our video guru here for at least our office and others.
Congratulations, Mr. Shoemake.
Thank you, Tim.
All right. Well, if you guys have not, first of all, I'll let Todd plug himself because he makes the most awesome videos. And he put together some of the Monsoon Awareness Week stuff, but he just goes around New Mexico and takes pretty cloud pictures and videos. What's the best place to find those, Todd?
Yeah. Well, we post a lot on our YouTube page, and yeah, we've been trying to plug the latest one. We did a little intro video for Monsoon Week, so that's on our YouTube page, and I think a lot of the other Southwest offices have also posted that to their YouTube pages. But yeah, if you just go to weather.gov, click on any weather service in your local area, most all of us have a YouTube link right there on our page. So that's where we post most of our videos.
Very good. Well, there's some good stuff there. I really like it. Finally, from the let's see, the San Diego office, we've got, is it James Brotherton?
Yeah, that's right. Thanks, Tim. Can you hear us okay?
And your lead forecaster there, and who else is joining you today?
We also have HMT extraordinaire, Larissa Johnson.
Larissa Johnson, very good. Larissa, how long have you been in San Diego?
Since January, so only 6 months.
So this will be your first monsoon season.
Yes, I left a really busy hurricane season in Hawaii to join San Diego, and so I'm excited for monsoon season.
Very good. And James, how long have you been there in San Diego?
About 2 years.
Very good. So you were actually here for not last summer, but the summer before there in San Bernardino County when they had the floods and the rains and things there.
Right. Yep.
I go to camp in our church has a church camp out there that we go to, and so I was very familiar because it rained like 2 to 3 inches up above San Bernardino just after we left. I was very thankful, but the campsite was completely flooded and they did lots of damage up there. So, very good. Let's get started today because today we are talking about downburst winds.
All right.
It's kind of interesting. It's not, yesterday we had a great conversation about lightning. Lightning has lots of myths built around it. Lightning has lots of visual things. Downburst winds a different kind of animal, and it's a little harder to explain. It's a little harder to visualize. I got a couple videos. I've got some graphics that I'd like to show. But let's get things started. First of all, if anybody has a question, feel free to tweet us a question, at hashtag Monsoon 2016. It's there on my let's see if I can get my finger. There we go. It's down there on my lower third. So feel free to tweet us any questions, and I'll be monitoring Twitter, and we'll ask them away. But let's throw it over to our Sue, our science officer, for a technical definition of what is a, I guess a couple questions. What's a downburst, and is it different from a microburst, or are those interchangeable words?
Oh man, it's like my big pet peeve around here, I would say. Downburst is just a rapid burst, really, of wind that comes down from this thunderstorm. That's the downdraft from the thunderstorm. It rushes to the ground, hits it, and spreads out. Winds are almost always going to be above 40 miles an hour, can approach or exceed 100 miles per hour, cause considerable damage. Probably 99% of the wind-related damage that occurs across the Southwest during the summertime during the monsoon is related to downburst winds. We can have the rare tornado, but most of it is downburst winds. You asked about the microburst and downburst terminology. It's really a qualifier based on the distance, and this was set by, put into print basically by Dr. Theodore Fujita back in the 70s and early 80s, and the definition really comes down to scale. A microburst is going to have a damage diameter of 4 kilometers or less, so that's about 2.5 miles. Anything larger than that is going to be called a macroburst. Now, so downburst, microburst, somewhat interchangeable, somewhat not. I prefer to just use downburst. I advise the staff in the Phoenix office to just use downburst and not get caught up in the terminology. Sometimes people just seem super hyped up. Was it a microburst? What was it, a microburst? I don't necessarily care. I mean, it's just kind of, there was a downburst that caused damage, and that's what we're focusing on.
So there up on my screen, I hope everyone can see, is a downburst from the cloud base. And so can you kind of walk us through how this works out here, Paul?
Yeah, so we're missing the top part, I would say, of the thunderstorm, too, which is important. So we have the updraft of the thunderstorm, and as that goes up, you have all the mass loading in the upper parts of the storm. So you have the updraft where the air is moving up in the thunderstorm, and those winds can be moving up at, going vertically up around 70 miles per hour even. So they can be very strong winds. You get all the raindrops and eventually the ice crystals and the snow, possibly hail that's lofted 5, 6, 7, 8 miles up into the air. And eventually what goes up must come down, of course. And so when the updraft is no longer capable of supporting all the water that is now up there, it starts to come down and it collapses and it rushes down to the ground. So you can see underneath from that cloud base is where that downdraft is coming. The precip loading is there, so you're going to have rain typically inside that downdraft. When it gets to the ground, it just smashes. It's like dropping a water balloon basically on the ground. And it bursts, and the water goes all out in different directions. And so you get that outflow front. Sometimes you get very, very heavy rain with these downbursts. Sometimes all the rain evaporates before it hits the ground, and you have the dry downburst or dry microbursts that form. The outflows that form these gust wrenches like you have there too can allow additional thunderstorms to develop too.
Here we go. I wanted to show this one because you talked about it being a weather balloon or a water balloon coming down. I'm thinking weather balloon. But you were talking about it being a water balloon, and this was this is a classic, wet microburst. But they put it together in an animated GIF. Before it was just still images, and you can see that just a big ball of water, blam, hitting the ground, and it starts to spread out. Pretty impressive.
If you show, let's see, let me go back to mine, if I can share my screen here. Hopefully you're seeing my PowerPoint animation here.
Let me see here. Here we go. Nice.
So this is radar, I believe this is from, looks like Nebraska. So these are some thunderstorms that developed there. On the radar, and you can see they start to produce downbursts, the outflow winds, and see them emanating out there. What you also see too is that how they start to interact with one another, and these outflow boundaries from the downburst can kind of take on an appearance and act like little cold fronts even. And so they start merging together and moving along and can cause additional thunderstorms to develop.
Now, just for the people who aren't, because we look at this all the time, and I immediately see the outflow boundary. But the outflow boundary is not the bright colors, but it's the line, that thin line that's moving off to the north and the northwest and northeast. That is what you're talking about, is the leading edge of that outflow air, right?
Correct. Yeah. So you see really pronounced there right at the end to the north, kind of wrapped around on the west, north, and east sides.
Very good. That's a great video, and it kind of really shows how that all spreads out like that. Well, monsoon, when you get these downburst winds, they can do damage, and I want to talk about specifically about the damage that they cause, or the threat they are to aircraft here in a minute. But Carrie, other than aircraft, what are some of the damages that you can get from these downburst winds?
Well, I think as Paul just mentioned, we just had an event just this evening, about 2 hours ago. We had wind gusts clocked at 60 miles an hour. That was on the east side of the state, and so we did not hear, fortunately, of any damage, but certainly you can have damage not unlike a weak tornado, an EF0 tornado, for example. So, Todd, you saw some of those effects just, as I said, a few hours ago.
Right. I think one of the things that we're really looking at was blowing dust. We had some reports of a wall of dust. Our Arizona neighbors and our El Paso neighbors are very familiar with that term, haboob. But basically, it's a wall of dirt or wall of dust, and those outflow boundaries or downburst can really induce those areas of blowing dust.
I know that one of the things that I got a picture here that I'll show here, a great picture of some damage but a lot of times the damage that happens over open terrain, you'll see just trees that are knocked down. But I have seen pictures of where it actually causes structural damage. It will do damage. It'll knock trucks off of the road. What other kinds of damage have you guys heard? And I'll throw my picture up here real quick.
Yeah, Tim, I'm glad you mentioned that. We've had several reports outside of Santa Fe, for example, just in the last, I guess, maybe 3 years, where we've had acres, and in some cases close to 100 acres or more of trees, of course, with straight line winds. The damage and the trees, of course, are parallel or laying in the same direction. So that's what we always kind of look for. But yeah, is that the Del Rio radar?
That is the Del Rio radar.
So yeah, you mentioned highway issues with trucks getting blown over, sheds. I know last year, I guess the other concern that we have, especially this time of year, a lot of folks during the weekends we have those portable tents, like weddings and receptions. And I think it was a couple years ago, one of those tents were toppled by winds that were probably 40 to 50 miles per hour. And so that certainly there was fortunately no injuries, but it's not just damage; it can be injuries as well.
For sure. Now going back to that picture, the story goes is that this happened at night. This was a downburst wind that hit this radar, and it's like it looks like someone took a big fist and just punched it into one of the Weather Service's weather radar. This is down in south central Texas, in Del Rio, Texas. And as the stories are told to me, that when the radar went down, they sent they didn't know exactly what happened, and they sent a technician, because the radar stopped working, of course, and they sent a technician out there, and it was at night, and he had to shine his flashlight up there and go, I guess I see why it's not working. So it is amazing. It looks like a fist just hit that. It's just amazing. Hey James, down there in Southern California, how often do you guys have to deal with some of these downburst winds?
It's actually more common than most people would think here in Southern California. First of all, one of the bigger threat seasons for us is during, of course, the monsoon season. With the monsoon, typically getting the monsoon fetch to come far enough west to actually affect the immediate San Diego area is pretty unusual, although it does happen. However, eastern San Diego County, including some of the Metro Valley areas, we do see more effects. Of course, it's not as common as out in the desert, but it certainly does happen here, as well as up in the high deserts of San Bernardino County. We get plenty of pulse thunderstorms during the summertime that could have the downburst potential. High base thunderstorms, typically most common in the high desert. So definitely a concern here as well.
What kind of damage do you guys see from downburst winds there? Is it mostly over rural areas like we were talking about? You've seen a lot of tree falls, or do you get some that do affect people and structures?
Typically, like you said, it's more in rural areas. But even there, we have a lot of travel through even the desert areas. So we have seen events where semi trucks get blown over. As well as trees down in the forest. We also, I think, Carrie may have mentioned the dust aspect to it. We get a lot of blowing dust with desert thunderstorm events as well. And then in the most populated areas, again, it's much less frequent, but we have seen, as recent as a few years ago, some downburst winds affect the San Diego area, with a lot of tree damage more in the city where we have a lot more vegetation.
You mentioned the blowing dust. I've got an animation here that I want to show that I found from our good friends at UCAR, or INCAR, and basically shows the thunderstorm as it produces that outflow boundary, how you can, as if it happens out over the open desert or an area where the soil's kind of loose, you get that wind comes down. Like Carrie mentioned, it can be anywhere from 30 miles an hour to 60, 70 miles an hour, and that's going to pick up that dust and blow it along. And again, if you're driving down the road, and we're going to talk a lot more about this tomorrow, but you get that haboob, that blowing dust can really reduce visibilities very quickly if you happen to be driving out on a road and that comes across you. So I thought that was a pretty cool video that I had found. Carrie or Paul, how about Paul? I got a question for you. There's things called wet microbursts and there are things called dry microbursts. What's the difference of those? And I think I muted you, so if you want to unmute your mic, you can talk.
Was that?
Yeah. I don't, I'm trying to think if there's a solid scientific definition for the difference between the wet microburst and the dry microburst. I don't really think there is, besides that you get rain or you don't get rain. Someone's I'm more than happy for someone to correct me on that.
But correct me if I'm wrong, though, it's different environmental elements that kind of give you that, where one is kind of dry down below to get you that dry system, where the other one's kind of dry above with a lot of moisture down below kind of thing.
Sure. We do see seasonal differences, I guess we could say. Like early in the season, we will tend to have more of the dry microburst, dry downbursts that happen. It's still very hot and very dry in this time of year, late June into early July. We don't get our big moisture push really quite yet. So the thunderstorm bases are going to be quite high, 10, 12, even 15,000 feet.
Mm-hmm.
That's, you're looking at almost 3 miles of air for raindrops to fall through and try to survive all the way to the ground, and they often don't. But as it dries, as water evaporates, it cools the air, and anything that gets cool gets heavy. The density increases, and so the air accelerates down to the ground, and so that's where you can really get a kind of an additional punch from the dry microburst. The wet microburst we get later into the season, especially into August. The air gets very saturated. The thunderstorms are going to be heavy rain producers, and so it's really when we start looking more flash flood threat at that point.
Very good. I got on my screen kind of a graphical depiction of the difference between a wet microburst and a dry microburst, but honestly, it doesn't, like you said, Paul, it doesn't matter. The result is the same. You end up with very strong winds at the surface, causing a lot of problems, whether it's dust or those real strong winds that can actually do damage, like Carrie said. Very good, very good. Let's see. I got Oh, now, Carrie, let's talk specifically about aviation. This is a specific threat to aviation, is it not?
It's a huge threat, Tim. In fact, here in Albuquerque, just do we have a graphic of that? Uh, in any case, we had a case was it last month where we had a very fairly fast moving, but we had a microburst over the airfield here at Albuquerque and picked up the dust. And in this case, they actually delayed a couple of aircraft that were on approach. And of course, yeah, that schematic there, that's the good one. There was the event back in 1985, some may recall, at DFW where we had the Delta flight. Unfortunately, they crashed short of the runway. So oftentimes, as in this case, an aircraft is on approach, it will encounter the upward arm of that rising motion as that rain shaft hits and spreads out, you create these eddies. And so the upward arm of the eddy, or the rising branch, if you will, if a pilot compensates for that rising motion and then a short time later encounters the core of that sinking air, rain-cooled air, that's really the issue. So you get tremendous turbulence, in addition to maybe some of the visibility issues that we've talked about. But yes, for aviation, it's a huge issue. Many of the airports have terminal Doppler weather radar, and there's been quite a bit of research of late to really kind of hone in on those, or at least trying to detect those areas of shear. But yeah,
Right.
we've had that here at Albuquerque just within the last month or so.
I want to get to Paul's picture, but I want to reiterate what you just said, because a downburst is the worst thing for a plane coming in. Just like Carrie said, as the plane is coming in, if it encounters those headwinds, the natural thing for the pilot to do is to pull back and to throttle back on the engines, because his or her plane starts to lift up. But very quickly they get into the middle of the downburst, it starts to force them down. And as they're trying to very quickly power up, they come to the backside of the gust front, where they actually, since the wind is moving them from the tail towards the nose, they lose all the lift on their wings, and they're going down already, and there's no way, even if they power up, there's no lift under their wings anymore, because the wind is going along with them as they're flying along. I don't know if people notice that planes only like to take off and land against the wind, and the last thing they ever want to do is try to take off or land with the wind. And in this case, at the very last second, the wind flips around on them, and while they're trying to compensate for one thing, the wind flips, and that's why it forces them down. And like you mentioned, that Delta Airlines flight at DFW, with so many people that lost their lives, was it wasn't the first documented microburst or downburst that caused a plane crash, but it was one of the more notorious ones. And I think it made a lot of changes on how we monitor weather around airports.
I think it does. And just as a sidebar, I was actually in high school in that year, Tim. I was flying back from D.C., and we went through the DFW area about 6 hours before that event. So
Wow.
It kind of sticks with me personally. So
Very good. Hey, Paul, what do you got there on your picture? Oh, you're still muted, sir.
So this is a picture that came from Las Vegas. It's a Southwest flight, you can see. This is Las Vegas Strip in the middle there, with the airport in the bottom left corner. So south is to the left and north is to the right. And you can see the downburst that's happening just to the west of the Strip here.
That is scary stuff, because, so people understand, the winds don't just stay right in that rain shaft. The winds will then immediately start spreading out, like if you imagine a water balloon being dropped on the table. They'll start immediately spreading out in all directions, and you see how close it's like 2 blocks away from the airport. So I imagine very strong winds all of a sudden came rolling across those runways.
Yep.
It's amazing, amazing. Well, I wanted to remind everyone again that if you had any questions about downburst winds, feel free to tweet us the question at use the hashtag Monsoon 2016. I had to think there for a second. So feel free to, like I said, feel free to tweet us those questions. It's just a scary thing to think about, some of these planes that are having to land. One of the things that I was watching a video about the Delta flight back there in the 80s was that their weather radar on the plane it wasn't, of course, set up to detect wind. All it was set up to was detect real strong thunderstorms. And so, like we've talked about, sometimes underneath these downburst winds, there's no raindrops at all. So it might actually look not that bad, but once you get into it, and usually by the time the planes get into it, it's too late for them to take much actions.
Tim, there was a nice time lapse out of Tucson. I think it was August of last year.
Oh, I got it.
Yeah, that was viral, of course, went viral. Yeah, that'd be nice to play. It really showed beautifully that just how small scale, and I think Paul mentioned it, how localized these events can be.
So this is from Tucson. It'll drop down right in the middle. It's kind of hard to see. And there it goes right there. Boom. Pretty impressive. I think it'll do it again for us. And then this big gush of rain came after it. So hopefully it'll back up. And okay, so you can see it kind of forming up there, and then it comes down, as we said, just like a water balloon hitting the ground. And then right after it is just this big rain dump. But you can see that what we call that dust foot, that wind gust. And it's literally like someone threw a water balloon, not like it dropped, like they threw it down there. Very impressive. Oh, one more time.
Tim, do we know if there was damage from that event?
I do not know off the top of my head. So just looking at it, you got to think there was some kind of damage. And then the rain that came after it was just torrential as it looks. So I'm glad you reminded me of that. So that's a great example of what it looks like in real life. And you can see it doesn't take too long for it to happen.
This was one here northwest of Phoenix as well, near Whitman. I know that did cause quite a bit of damage.
What kind of damage was it? Do you remember what kind of damage it was?
It's usually structure. I mean, here I had a picture here. This is the kind of damage we would typically see. You see a lot of the trees in the background, or there's trees tipped over, branches. This is a car, a car shading got peeled back, and this was from a real significant event we had back in 2008. I can have a radar loop here that shows this. I mean, it's a little bit. I mean, these are downbursts, but they're not the pulse type downburst that we are really talking about here that we get a lot in the Southwest. This is a little bit more organized, but still downburst winds nonetheless. That happened in Phoenix. We had several waves of storms that moved through the metro area, about 5 or 6 waves. And at some point here, I'll switch over. Phoenix is in the center basically of this, and the airport's right in the middle. So here's the velocity of the radar, and the radar's kind of in the bottom right corner, and so anything that's green is moving towards the radar, anything that's red is moving away from the radar, and so you kind of see a lot of those reds and whites just kind of went through there downtown.
Mm-hmm.
And that was some really significant winds. If I flip over this one here, this was the strongest winds that the radar was picking up. So this is about 9:37 that night, right over downtown. The radar is looking about 1,500 feet above the ground, and the winds here, it says, are 110 knots moving away from the radar.
So, what's 110 knots?
110 knots, probably like 125 miles per hour.
Okay.
So, I mean, it's strong. We had the ASOS itself at the airport, I think, measured, if I remember, at a peak gust around 75 miles an hour. There's a center field wind sensor at the airport, which is about 100 feet up off the ground, and I think it came in at right around 100 miles an hour.
Wow.
And so this caused a lot of damage, kind of like this, in a very broad area. Actually, it's fortunate that it came in later that night. I mean, the airport, they had shut everything down. We were really on top of it. I mean, I was working that night. I remember calling the airport about 15 minutes before it came in, just saying, like, you got a hell of a storm that's going to be coming in here real quick. So they had shut things down. But they had so much debris on the runways from the trees and everything in the nearby area that they just had to stay shut down overnight. And they brought in, I think I remember reading, about 25 street sweepers from all of the Phoenix and nearby cities so that they could clean the miles and miles of runway that they had that were all strewn with debris now because they couldn't land any planes.
Wow. Well, very impressive. Oh, I was one thing I was gonna talk about with people, because some people might say, well, how does that wind get going? How does it get going so fast out of a thunderstorm like that as it drops down? I think we all have, or most of us here in the Southwest have evaporative coolers for our homes. I know in Phoenix, you guys are almost a little too warm for evaporative coolers. You may have AC and evaporative coolers, but a lot of us in the Southwest have evaporative coolers to keep our houses cool. And you all you're doing is wetting some material and then pulling air through it, and through the evaporation and cooling, it makes it colder and it comes into your house, and hopefully it cools off your house. Well, we all know, or maybe you don't know, but intuitively, if you see the hot air balloons, hot air rises, but the opposite happens. Cold air sinks, and if it gets cold enough, it's going to sink very quickly. So if it's kind of dry near the surface and you've got a thunderstorm going along, and all of a sudden you got raindrops in there, and you get that evaporation going, that can start to cool that air, and you get more raindrops in there, and it can cool it some more. And if the conditions are right, you get like that big ball. And that cold air all of a sudden is much warmer than the air around it, and it just drops down to the ground like a wet balloon, like we've been saying over and over again. And that's why it can start building up those speeds so quickly as it drops out the bottom of those thunderstorms. Hey, James, and I don't mean to put you on the spot here, but because Carrie or Todd or anyone can answer the question, but how, as a forecaster working the radar, since we've been talking about how small scale this is, and it seems like it'd be kind of tough to see, but is there any tools that you can use, or any way you can detect this with the radars that we have?
Yeah, Tim, with pulse thunderstorms, you have to be really quick, because while they're pulsing up and down, there are several tools when you're analyzing thunderstorms to look for some indicators of the potential for these downburst events. One thing we want to look for is the high base reflectivity, and what happens is you can start to see the core of the thunderstorm starting to basically drop out of the storm. So that's one of the big indicators, would be looking for the core aloft based on the reflectivity. We're also looking for, we can look at the wind, the velocities as well, starting to develop at low levels. So it does depend on the resolution of your radar. Of course, your distance from the radome is a big part of detection of a fast unfolding pulse thunderstorm event with a potential for a downburst. So, like you said, there's definitely some good indicators there, and once it's actually happening, we can actually see some debris on the ground in some of the strongest cases. But yeah, those are some of the indicators that we'd be looking for, especially that core aloft.
Right. And that's the trick, is looking for that core aloft as it starts to drop down. On my screen, I've got a radar velocity image. Can you kind of talk us through what we're looking at here? Because I know a lot of times we meteorologists like to throw these images up, and to a lot of people it just looks like a bunch of colors on the screen. But once you've kind of like a doctor who's looked at thousands and thousands of X-rays can very easily see a broken rib versus a not broken rib. We look at these radars images and we see the patterns all the time.
Yeah.
So kind of talk us through what we're looking at here as far as the downburst signature.
Well, it's a little confusing when we talk about straight line winds. Basically what we're seeing here is when, as Paul mentioned earlier, is the downburst, it's basically like a water balloon, and when it hits the ground, it spreads out sort of in a radial pattern. So what we're seeing is the center of the downburst and those winds spreading out in a radial pattern around the strike of the downburst. So you can see those high velocities spreading out from the center, and it actually causes, like I believe Paul mentioned earlier, it's like miniature cold fronts leading out in radials from the center of the position there.
Now, in this case, this is a velocity from the radar, and the reds kind of indicate that the winds are moving away from the radar, and the greens indicate that they're moving towards the radar. The radar, I believe, is down here in the lower right-hand corner. So in this case, if you kind of imagine, there's just the winds to the left of these arrows are moving, to the northeast or to the northwest, and these that are in the green, they're actually moving off here to the southeast. And just right here in the middle is where you had that microburst. And these, like you mentioned, James, that you had the bright colors here. Those are very strong winds right at the surface. So that's right where that water balloon hit the ground and moved off in different directions.
Right. Another thing, I was going to mention earlier when we were talking about. Actually, I'll let you go ahead and maybe at the end we can reflect back on a few things.
No problem. No problem. Let's see. We've covered kind of the AV. Oh, I want to. Hey, Carrie, or maybe Paul. I don't know. For us as meteorologists, we have ways of kind of detecting these microbursts. But is there any way for like someone in the general public, just by looking at the skies, trying to figure out, is today a day that they might more likely see a downburst or these kind of downrushing winds?
Well, I would say certainly here in our area, Virga. Have we talked much about Virga yet?
No.
So that's the visual evidence. We're talking about rain-cooled air, the precip that evaporates. So at least for us, I mean, if you look on the horizon, we always tell folks, if you see the Virga, they make for beautiful sunsets, right? The photos. But to always look toward the ground, because oftentimes the Virga is a strong indication that rain-cooled air. And I think as Paul mentioned earlier, our bases can be 12, 15,000 feet above ground. So I would say Virga is your first very good clue for the folks that are out watching the horizon. So
I got an image here of some Virga.
There you go. So I would say Todd has captured some great images, both time lapse, but just images of Virga. We have quite a bit of it. In fact, I would say it's our preferred, at least in terms of reports. We get more reports of Virga than probably anything else this time of year.
Very good. And like you were saying, just because just because you see Virga doesn't mean that something is going to happen. Because I think in a lot of these images, you don't have a very strong thunderstorm associated with these clouds. But if you do see Virga and then thunderstorms do start to pop up, that might be, like you were saying, that's an indicator that it's kind of moist up above, but it's much drier down below, and we could definitely see the potential, especially for those dry microbursts during the day.
Sure. Yeah, in those cases, the case we had just last month, Tim, it was no lightning, just high-based Virga that moved over the airfield, and we probably had, at least on radar, indications of at least 50 miles per hour. So
Wow.
You don't necessarily need lightning to get these impacts.
And that's something for people to remember, because we talked about yesterday about how you hear thunder, if thunder roars, goes indoors. This is something that you really just need to be paying attention to, the weather. And sometimes even when you're watching it, if you're watching a thunderstorm come up, we've all seen lots of thunderstorms come up and we go inside, but every once in a while one of these will drop one of these water bombs on us, or in the case of a dry microburst, it'll be just a big gush of dry air down, and it does lots of damage.
We like to call them Virga bombs.
Virga bombs, very good, very good. That's a great term. Again, if anyone has any questions, feel free to tweet us a question at Monsoon, hashtag Monsoon 2016. I'm trying to think what else we need to cover here. I guess what would be some safety tips as far as people could do to take action. I know since it kind of is hard to see it coming, just the same thing as with a thunderstorm, to maybe go inside. Would that kind of cover things?
I would say so. I was going to ask Todd, as a forecaster, I think we do pretty well recognizing, Tim, the overall environment. Today was a good example, but trying to pinpoint, where is that going to occur precisely. So one thing that we've done here locally is we tend to put out more of a blanket statement, and maybe, Todd, you'd like to just to kind of highlight the potential without, getting too specific.
Right. I think that's the bigger thing is we look at the environment, the overall bigger picture, and then we try to highlight that because a lot of times it's very difficult, if not impossible, to even see these things on radar, especially when we're talking about the drier downbursts. We talked a little bit about some radar examples, but those were more of the wetter variety. Those with the drier variety, you don't have the rain that's getting picked up by the radar, so it's a lot harder to see it. And then the other thing, I guess, that I would point out is just the temporal scale of these. It happens very fast, so a lot of times the radar will be spinning around doing its full revolutions, and these can happen before that even completes itself. So sometimes we may not even see it until we get a report of a strong wind gust or some dust or something like that.
On the screen here, I just have another depiction of what the difference between a dry microburst and a wet microburst. We've kind of been talking about them, how for the wet microburst, you've got the clouds very near the ground, and you still get the dry air kind of working in from the top, and it drops that water, that Vergabomb down on the ground, or that water balloon down. Whereas here, for the dry microburst, you see you've got the clouds are up high, but since we're so dry, it's got a high cloud base, and then you've got that Vergabomb drops out of the bottom of the cloud. So, but again, it doesn't really matter if it's a dry microburst or a wet microburst. The result is the same. You get very strong winds down at the surface, and they can do damage. And then, like we mentioned, they could also be threats to aircraft. Carrie or James, do you guys, what are some other threats that are these dry microbursts or the wet microbursts? Is there any other kind of industries, or, we talked about aviation, we mentioned forest, blowdowns of forest, damages to structures for people. Is there any other kind of things that these dry, very strong microburst winds can do damage-wise?
Yeah, definitely to infrastructure, like you mentioned, also along the highways, definitely a big impact to any travel going on, and also railroads. The rail lines can be affected, obviously. Let's see, I can't really think of anything else. I was going to mention one other related, kind of anecdotal versus a safety issue, but sometimes when you get those high-based dry thunderstorms, dry downburst, one thing I was going to point out is that sometimes you actually get warm air reaching the ground. Once that air, if it's dry enough, you actually get compressional heating as the air reaches the ground. So one thing people would notice out in the desert is sometimes you don't really see that cool air rushing out of the thunderstorm. Instead, you can actually get what's called a heat burst if it's a real extreme case, where the temperature actually jumps up very fast during one of those dry downburst events.
Exactly.
Do you have any other, can you guys think of any other effects, possibly? I think aviation is probably the biggest one.
It is the biggest. I was going to add dry lightning, Tim. It's not, in terms of starting wildfires, we have, and then of course you can get the wind effects with that. So it's never good to have lightning without much in the way of precipitation in terms of wildfire environments. And a couple of our fires that are ongoing as we speak are as a result of those dry lightning strikes.
So there's all kinds of threats that we have during monsoon season, and I've been checking. I don't think we have any questions on Twitter, but one of the direct results of these downburst winds is blowing dust. And we're going to spend a lot of time tomorrow talking about the threat, the hazard of blowing dust. So that's actually one specific threat caused by these downburst winds. But of course, we can get blowing dust from just some straight line winds, and other mechanisms can give us some blowing dust. So tomorrow we'll be hitting hard on the blowing dust aspect and how it's a hazard to travel and everything. So I didn't want to touch on it too much, but that is one of the main threats that we do get with these downburst winds, is especially here in the Southwest, we'll get that blowing dust, and then you get all kinds of issues related to that as far as trying to travel and transportation, and we'll cover all of that tomorrow. And actually that's where we see a lot of our fatalities here in southern New Mexico is people who drive into these dust storms that are caused by these thunderstorm outflows, and they don't know that they stop, and people behind them, the trucks behind them, don't know they've stopped, and we end up with cars and trucks slamming into each other, and that's where you end up, unfortunately, killing people and injuring several people.
Yeah, very true. I was just going to add too, I think Todd alluded to it, Tim, is that, we mentioned, I think James mentioned, as you get away from the radar location, it's so very difficult to detect and warn for these events. And so I think it's important for folks to know that in our discussions, right, our forecast discussions and the products that we put out, they're oftentimes on those big days when we see the potential for these Virga bombs, downbursts, microbursts, to just kind of keep a heads up and plan, right? Plan accordingly. We've said that all week so far, but it's so very true that if we see that potential to at least know that, don't be caught off guard if you get, wow, where did that come from? Because I think we tend to get a lot of that. So.
Yeah, and one of the things that comes to mind is the event we had almost 3 years ago, big outdoor concert, and I know you guys kind of talked about this with lightning yesterday, outdoor concert events, things like that, but we had well, I guess technically a macro burst, but basically a downburst wind event that happened while we had a big outdoor concert event going on. And probably people didn't take shelter fast enough, and we recorded 89-mile-per-hour wind gusts.
Yeah, in fact, it's the strongest, I think.
Strongest on record here at Albuquerque. So yeah, they can sneak up on you, but I mean, we do try to highlight the environmental indicators when we see them.
So I guess the takeaway for people today is it's very difficult to actually just look at the clouds and go, okay, today's a microburst day or today's a downburst day. And unless you're a really trained meteorologist to be looking at the radar to kind of see that something's developing. So the best thing for people is just to, like Carrie said, is to be aware of the threat of downburst. You might look over some of the hazardous weather information that comes out of your local weather office, because like Todd said, the forecasters on shift will try to highlight the days when we believe that downburst winds are more likely to happen. And if you do see those words, because we don't issue necessarily like a downburst watch or something like that, so you just need to be aware that the potential is that day, and if a thunderstorm rolls up on you, you need to treat it very seriously, as you should anyway, because whether it's the lightning, the heavy rain, or in this case the downburst winds, take any thunderstorm seriously, especially on days where it's been highlighted by your local weather service office as far as the potential for downburst winds are. So, treat it carefully. If you see one coming up, go inside into a nice sturdy building. I guess we'll finish things up because we're getting actually towards the top of the hour. Talk about maybe one. Todd, you already did one, so maybe it'll be Carrie's turn. Talk about one downburst wind event, and then I'll tell a story that I have. Then I'll have Carrie, and then James. You can kind of wrap things up, and then we'll wrap things up for the night. Again, last chance. If you want to ask us a question about downburst winds, feel free to tweet us at the hashtag Monsoon 2016. I've got it there on my lower third. One of the challenges here in El Paso is that our office and our radar is over on the west side of town. And for those of you that don't know, right down the middle of El Paso is a mountain, the Franklin Mountains. It's not very tall, 8,000 feet, but when it comes to trying to peak the radar to the east side of town, it can be a real challenge. And what happened is that we had a thunderstorm pop up on the east side of town, and like I said, it's very hard already to detect these things on radar, and you throw a big mountain in between you and the thunderstorm, and it makes it very difficult here in El Paso. And this thing dropped one of these wet balloons on the east side, again, very isolated, but it tore the roof off of an apartment building over on the east side of El Paso, not far from where I live. So the challenges for people in the Southwest as far as downburst winds are significant, and even for the meteorologists, the forecasters who are watching radar, trying to just detect these and give people warnings. We've kind of hinted at, but this can all happen very quickly. I think it was Todd that mentioned that our radars, they spin around, and just so people understand, they take a sample at one elevation, and then they click up a level, and then they go around again, they click up a level, and they spin around again, and they go through a cycle, and then once they get to the top, they drop back down and start again. And that all can happen very quickly, and we actually have new algorithms that can actually run it much even faster. But like Todd said, we can get through a half a volume scan or half, the radar going around, and it's already happened. So it is a very difficult challenge for us in the forecasting community to detect these things and get the warnings out ahead of time to give everybody out there just the chance to seek shelter before these things happen. But I think it was James that talked about, we have developed some routines where you look for that middle layer where kind of that ball is looking in the middle of the storm, and once it starts, the core of that storm starts to drop down, that's one sign to us as the radar operator, as forecasters, that something's coming down. It's like that water balloon starting to drop. So many times we'll issue that warning to try to get a heads up on it. So Kerry, what's a downburst story that you?
Well, I was working the evening of that 89 mile per hour wind, Tim, and it was frightening, to be quite honest. Actually, what I heard first was little tiny pieces of gravel getting thrown into our window.
Wow.
Yeah, it was, and that you realize, wow, okay, this is a serious. What I wanted to mention, I had an event at our house where we had our outdoor lawn furniture, and of course we have one of those umbrellas, I guess, that you put up and down. And I wasn't smart enough, even though it was a day that I think we had highlighted, probably Todd was working, and I didn't do my due diligence that morning, right? So, I mean, if the potential is highlighted, do some work, get the patio furniture secured, and I didn't do it. In any case, long story short is our umbrella was straight up and a couple blocks down the road, and not in good shape. So we got a new one out of it, I guess, but it's not always the big, it can be just a moderate wind that can do damage.
Sure, and you bring up a good point, because during the spring, especially in Arizona and New Mexico, far west Texas, even Southern California, during the spring we're pretty used to once or twice a week we get real strong winds. So you just have everything is tied down, everything is pulled in. You don't have lawn furniture and umbrellas sitting up in your backyard because that in 2 days it's going to be strong winds again. So, we have that all tied down. But once we kind of move out of the windy season and we move into summer, people start to open their pools, they start to set up their furniture, they're much more likely to be outside. And I've seen plenty of stories where you've got those, and I've got one myself, it's a beautiful glass patio table, and it takes nothing because you get that wind underneath those, and they're pretty heavy, and the wind will lift it up just enough and drop it back down, and guess what? Shatters all that glass. So, a lot of people like to set everything out, they get ready, they want to enjoy the summer, whether they've got a pool or they're just hanging out in the backyard, and they set out furniture and everything, and then you can get one of these storms coming across, and oh man, like you said, Kerry, those are just missiles waiting to happen with all the lawn furniture. It's made kind of aluminum, light. It can start blowing around. I know once I found lots of my lawn furniture in the pool as it got all blown in there. But you can get damage from the patio table being destroyed, or like Kerry said, little Mary Poppins action as your umbrella flies down the street. Hey James, what's a story that you guys have for downburst winds there, Southern California?
Oh gosh, well, I was actually thinking of something from my childhood, if that's all right.
Oh, that's fine. Yeah, we love a good story.
I can't think of anything in the immediate area here, but I sure do remember when I was a little kid in Indiana. We lived about half a block from a large city park, and we had a microburst hit the park in Terre Haute, Indiana. I was probably maybe about 7 or 8 years old, but the fully grown, mature trees, and pretty much almost every tree was knocked over in that park, and it was quite a sight to see. It was really awful, but it was quite a sight, for a little kid that really is interested in the weather.
Is that what got you interested in the weather?
For me, it was really the winter storms that got me interested.
But I'm sure that didn't.
But that certainly helped, yeah.
Very good. Well, I don't want to go on any longer unless you guys have anything else to say. But again, let's kind of, Carrie, kind of cover what are the safety tips for people relating to, downburst winds if they're driving or if they're just happen to be, they have their backyard all set up for a pool party.
Yeah, or both, right?
Or both.
So yeah, I think the best thing is plan. Obviously, keep in touch with the forecast and know what to expect either that day, or if you, in this case, planning a weekend activity. If you're caught, I think we mentioned earlier, your best option is to get inside a strong building, your house, something of the like. If you're caught out, you're going to talk about this tomorrow, but there's the saying, pull aside, stay alive. So you stop, pull off the roadway as far as you can, and wait it out. I mean, these events, as quickly as they develop, Tim, they are gone, right, in a matter of minutes. Mm-hmm. So we're not talking about a great amount of time to, wait it out. So I think those are the things I would say in terms of safety.
And I guess it's a little more technical, but if you're a pilot, not maybe of a major airline, but of small aviation, general aviation is the word I'm looking for, again, you got to get that weather briefing. You need to be aware of where the thunderstorms are, and if there are thunderstorms, maybe you don't fly that day. It just might not be a good idea because, we kind of mentioned the Delta flight that was back in the 80s at DFW, but I've seen untold number of stories, and matter of fact, one was here at Santa Teresa Airport where our office is located, where there was just a little thunderstorm at the end of the airport, and the plane took off into it, and it just forced it right down to the ground. So if you think these winds can knock down these big commercial jet airlines, you can only imagine how easily they can swat some of these general aviation small planes out of the air. So, any last thoughts there, James?
I was going to bring up something that we were kind of arguing about here in the office earlier today, was using the term dust storm or haboob. Have you guys have any rules of thumb for geographically using the term haboob?
I know that right now there's a bit of a controversy. The technical term is haboob, and we'll talk about this probably more tomorrow, but I know that some people, for some reason, A, they don't like it how it sounds, B, it's an Arabic sounding word, so they don't like it. I know that the Lubbock office recently, they posted a picture and said it was a haboob, and they got some pushback from people saying we call them dust storms here in West Texas. And but I got no problem. We have monsoon's an Arabic word, Chinook. We use all kinds of words for weather around the world, so I've got no problem with using the word haboob, and I usually use it associated with just a big wall of dust. What do you think, Harry?
Yeah, absolutely agree. I mean, tornado, right? The origin of tornado, tornado, Spanish origin. So there's a lot of weather terms that are, have origins outside of the English language. So I think, like we said, I mean, versus the semantics on it, I mean, the impacts are the same, right? Whether you're in West Texas or in Palm Springs, California. So the important thing is to know what to do when you encounter a haboob or a wall of dust or a dust storm.
Well, very good. I want to thank everybody for joining us today. Great discussion on downburst winds. Join us same time tomorrow. We'll be tweeting out and posting the links. We'll be talking about dust storms, that wall of dust. We'll be talking about haboobs. Maybe we can talk about the term haboob and what it means, some of the impacts related directly to those big walls of dust. But I want to thank right now Carrie Jones and Todd over in the Albuquerque office for joining us, and James Brotherton over in the San Diego office for joining us. So you guys did a great job. Thanks for joining us. I want to thank everybody out there on YouTube and Google Plus that joined us and watched the video. Like I said, we had a great conversation, and if you've got any questions about downburst winds, feel free to contact your local National Weather Service office. So without further ado, we'll sign off, and hopefully you'll join us tomorrow as we have a great discussion about dust storms. So thanks, and have a great evening.
Thank you.
Good one.